Okay, for these ones, we've got definite integrals because they've got limits on them. So let's have a look at A. If we were integrating any exponentials, the way I like to do exponentials, and we do have limits, so I better put them on. I like to remember that if I was differentiating, I would need to put a half out the front. So I need to, when I'm integrating, I need to divide by a half. So I really need to put a 2. And then it's the same. Exponentials are boring, right? So they're always the same. All right, the 2 I don't really need. I can put inside the and do the substitution, or I can just leave it outside. All right, so when I do this, I get e to the power of 2 minus, now sub in 0, so that's e to the power of 0 or 1. So our answer there would just be 2 lots of e squared minus 1. All right, so that's a definite integral. Okay, so if I look at B, we've got sec squared 2x there. Now, you may want to, if you want, do the U method or say, what's the f of x? If it was just sec squared x, I know that integrates to tan x, but it's sec squared 2x, so 2x is going to cause me a bit of problem. So if I have a look, I really need a 2 to be there. In order for a 2 to be there, I can just put a half out the front. So for B, I'm going to put a half out the front, and then I will have the 2 to balance. So now I've got the 2 sec squared 2x. Once you've got the derivative there as well, you can just do it straight from the reference sheet. So that's a squared there. So tan squared, sec squared integrates to tan. So I've got tan of the function, which is 2x, between 0 and pi on 6. Now when you do that, don't forget we sub in the top first. So here you've got tan, oopsie daisies, here you have, nope, sorry about that. We have tan of 2 lots of pi on 6's, so pi on 3, and minus tan 0. Okay. So we know that is the same as tan 60, which is root 3, and tan 0 is 0. We should know those exact ratios, exact values. So root 3 on 2 is our answer for that one. All right, let's have a look at C. So C looks like on your reference sheet the one that is 1 over a squared plus x squared, where our a squared in this case is 4 squared. So I might just write it like that. All right, so that really just comes straight from your reference sheet. So have a look at your reference sheet and you'll see you need the 1 on A out the front. So in this case, our A is 4. So you need 1 on A. And if there's a constant out the front, I rarely include it in the substitution part because you don't need to. You just put it out the front. And it's x on A, so it's x on 4. And we're going between minus 4 and 4. So in this one, we've actually got sub in the 4 first, so inverse tan of 1 minus inverse tan of minus 1 if we sub in the negative 4. All right, don't forget for inverse tans, if you remember back to your trig and extension 1, we are restricting, when we do inverse tan, we restrict to the first of the fourth quadrants. So from 0 up to 90, but not including, and 0 down to minus 90. So we're in these two quadrants, so just be aware of that whenever you're doing your inverse trig. So inverse tan of 1 can only be, with our restrictions, it can only be pi on 4, and inverse tan of negative 1 be negative pi on 4. When we put that together, we get pi on 4 plus pi on 4, which is pi on 2, and a quarter of pi on 2 will be pi on 8. So that one is C. All right, so when we look at D, it also looks like one in the reference sheet where we have the inverse sign. So we have a square root of a squared minus x squared. So I'm going to put it in that format to help me. So I'm going to have 0 to 1 and 1 on square root of, so this has to be something squared, so it's going to be root 2 squared to give me the 2 minus x squared. Sorry about that circle, which should be a bracket. All right, so that's root 2 all squared minus x squared. Okay, so we could go straight to the formula booklet, the reference sheet, and you can see that should give us the inverse sine of x on whatever a is, and a here is our root 2. We're doing it between 0 and 1. So again, remember for inverse sine, it's also restricted to the first quadrant and the fourth quadrant, just in case that helps. So we're subbing in 1 first, so we've got 1 on root 2. Whoops, there we go. Subtract, now we're subbing in 0, so inverse sine of 0. Okay, since it's only positive in that first quadrant there that we're looking at, we've got pi on 4 minus 0, which is just pi on 4. Alright, let's look at E. So with E, if you have a look at, basically it's a fraction. And so when we have fractions, we think maybe it's a log. Now, oops, let's go, that's actually a minus 2, sorry, and a minus 1. If I differentiated the bottom, I'd get negative 3. So remember, for it to be a log, we need f dash of x on the top. So we actually need a minus 3 on top, so I'm going to put a minus out the front so I can put a minus 3 on top. There we go. So now straight away I know it's negative log of the bottom, straight from the formula sheet. We've got minus 2 to minus 1. Now a little tricky, if it's got a minus out the front, so you can just do it the opposite way. So you can do exactly the same thing, but so I don't really need to use it. I can do this, and I can just swap these limits around. Then I don't need to worry about the minus. Up to you if you want to do it or not. All right, so here we've got log of, we're going to sub minus 2 in, so we're going to get a positive 6, 7, 8. We don't need the absolute values because 8 is already positive. Oops. So we can just put 8, as it were. Just leave it as 8 minus log of, and if we sub negative 1 in, we'll get 5. So using our log laws, we know that is log of 8 on 5. There we go. All right, so the last one, you've got coses and sines here, but sine is cubed. So when we just look at, maybe have a look at where we could get cos from, well, we get that from differentiating sine. All right, so it's a simple one. So now we've got the derivative there. You can think of it as just integrating sine cubed, as long as the derivative's there. So here we've got 0 to pi on 4 cos x sine cubed x dx. When we do that, we add 1 to the power, so it becomes sine 4 to the power of 4x, and we divide by that, so divide by 4. Now that 4 doesn't need to be, it's a constant, so it doesn't need to be inside those brackets. All right, we're going to sub pi on 4 in first, so I might put that quarter out the front. So I've got sine pi on 4, and that's going to be all to the power of 4. And minus sine 0, which we know is 0 anyway, and that's going to be to the power of 4. So I've actually got a quarter times, now sine pi on 4 is 1 on root 2, to the power of 4 would be a quarter. So you've actually got a quarter times a quarter, which is 1 on 16. Okay, so that one you could have also done using the u's. Some people find more confusing. If I made u equals sine x, then du equals cos x dx. And you can see that whole part, cos x dx, would become du. Now, you've got to be a bit careful if you're substituting a u, because these limits here and here are in terms of x. So what sometimes you can do to cheat, and we'll do more substitution properly later, but this du is cos x dx. So now I've got u cubed du, and I'm just going to leave the limits off because they won't be correct. I could change them by putting the x's in here and getting new u limits instead. Or I could change the answer back to so that would be plus c, but I don't really need that because I'm going to change the u back to sine in terms of x, and now I can put the x limits back on. So sometimes a bit of a cheat method here is to forget about the limits if I've done a substitution, but then once I've got it back in terms of x, I will put the x limits back on. Okay, so that's just another way. Hope it helps.